Welcome back. This is Unit 3.1. This is Secondary Math 2, and we're covering greatest common factor. All right. So, first thing, let's do some examples. All right. So we've done this before. To simplify, we would distribute. Okay. So distribute would get 10x squared minus 6x plus 14. All right, so we're just multiplying each term by 2, and that's what we get for our answer. Okay, so let's do another example. Here we're going to distribute a variable. Okay, here we would get an x squared minus 4x. All right, and then we could do a combination of coefficients and variables. Okay, so we're going to multiply each of these terms by 3x squared. That would give us 3x to the fourth. So remember, if we have the same bases and we're multiplying, we add those exponents. That's exponent rules. So that would be minus 6x to the third plus 24x squared. Okay, so we went over this a lot with exponent rules and multiplying polynomials and things like that. Okay, so the process that we just did is called distribution. Okay, so we distributed a number or a variable, or both. Okay, but sometimes we're given a problem where we want to undo that distribution. Okay, so that process is called factoring. Very similar to like when we have 12 and we want to do a factor tree. So a factor is something that you can, basically what can we divide from 12? That would be a factor. Like a list of all the factors of 12 could be 2, 4, or 3, 4, 6. Those would all be factors of 12. Okay, so we want to find the common denominator, or not the common denominator, the common factor, so that we could factor things out. All right, so for factoring out the greatest common factor, the GCF, here's some steps. So a factor is a number that divides evenly into another number, kind of like what I was talking about before. What is the largest number or variable that all terms can be divided by? Okay, this is called the GCF. All right, one thing that we need to remember is that if the leading term is negative, then the negative is part of the greatest common factor, the GCF. Okay. Another thing that I should probably put maybe in front of factoring out the GCF is we need to make sure everything is in standard form, meaning that we have the highest exponents first. So for example, something like 3x to the third plus x plus 2. That would be standard form. We have the highest exponents first down to the constant. And we talked about that before. So this would be the first thing that we would always do would be standard form. All right, so let's look at A. What would be the greatest common factor? What is the greatest number that we could divide all three terms by? Okay, you would look at that and say, well, they're all even, so it looks like we could probably divide all of those by 2. All right, so this is the steps to find out to factor out the greatest common factor. So we'd put a parenthesis, we put what we say is going to be our greatest common factor, and then if we're going to multiply something by 2, we also have to divide it by 2 so that we're not changing anything. All right, so here we would have 2 out there first, and then we would just need to simplify. So 10 divided by 2 gives us 5x squared. Negative 6 divided by 2 gives us a negative 3x. And then 14 divided by 2 gives us a positive 7. All right, so this would be your answer. We factored out the greatest common factor. All right, so let's do some more examples. Pause if you can and do B, C, and D, and then see how you did. Okay, looking at B, greatest common factor here would look at all four terms, and we'd say, well, it looks like we can divide all of those by 5. So here would be our greatest common factor of 5. But if we're going to multiply everything by 5, we also need to divide it by 5. So we'd have 5 times 15 divided by 5 gives us 3x to the third. Negative 5 divided by 5 gives us a negative 1. Okay. Just like you've done before, if we do have a 1 in front of anything, we don't need to keep it. We could just write it as negative x squared. But if you prefer to have the 1 in front, that's fine. Okay. Negative 20 divided by 5 would give us a negative 4x. And then 5 divided by 5 would give us 1. Okay, so here's another example of factoring out the greatest common factor. All right. Next, put our parenthesis, figure out what can we divide 27 by and 30 by. Maybe you'd say 3. So here we could do 3. We could divide everything by 3. So we got 3. 27 divided by 3 gives us 9x. And then 30 divided by 3 gives us 10. Okay. D, again, one of the stars that we have is that we need, if we have a leading negative, like we do here, we need to factor that out for the greatest common factor. So here we would put our parenthesis, okay, our greatest common factor would be a negative 1, so that we get rid of that leading negative. Divide everything by negative 1. So we will have negative 1, or you can just have it be negative. Okay, negative x squared divided by a negative 1 would give us a positive x squared. And then we'd have a negative 3x and a positive 4. All right, so it may not be apparent why we are doing this so far. Like, why are we factoring out the GCF? Why are we factoring out leading negatives? And that will become apparent when we get into different types of factoring. All right, so just trust me on my word for now, and then you will realize why we're doing that. Okay, so greatest common factor includes the leading negative. All right, so let's look at example 3. So here we're going to factor out the greatest common factor, but this time we're not factoring out numbers, we're factoring out variables. Okay, so let's look at A. Here we have 2 x's, here we have 1 x. Okay, how many x's can we take from each of these terms? All right, well, we can only take 1 x out of here, so the only thing we could take from this one would be 1 x as well, because if it makes any sense, we can't, if we take 4 x's out of here, we can't take if we take 2 x's, or x squared, 2 x's out, we can't take 2 x's on the right side because there's not enough to take away, all right? So the greatest common factor for this one would just be x, and then we would divide everything by x. So we'd have x times, all right, if we look at the first term, x squared divided by x. Okay, if we look at exponent rules, whenever we have something like x to the a over x to the b, well, that is the same as x to the a minus b. So all we're really doing is subtracting these exponents. Okay, and this would be like a 1 on the denominator. Okay, so it would end up having x, and then x divided by x, well, x, something divided by itself is always going to be 1. So we'd end up just having a negative 4. Sometimes people say, well, that just cancels. Okay, and we would cancel out one of the x's on the first term. All right, so that would be our solution. Let's do some more examples. Okay, greatest common factor. Okay, here we have 3 b's, here we have 2 b's, here we have 1 b. So the most that we can take from every term would be 1b. Okay, so here would be b in the front, we'd divide it all by b, would end up having b times 3b squared plus 2b minus 4b. Okay, so basically what we're really doing is we're taking a b from here, we're taking a b from here, and we're taking a b from here. Okay, another example. Now looking at this, I told you the first thing we need to always do is have it in standard form. This is not in standard form, so we would have 2m to the 8th plus 8m to the 6th minus 7m to the 4th. Okay, so we would look at the variables. If we look at the numbers, there's nothing we can factor out for the numbers. There's nothing that we could divide 2, 8, and 7 by, except for 1. And if you factored out a 1, that wouldn't really do anything for us. Okay, so we'd put our parentheses, and we'd want to say, well, what is the greatest common factor for the variables? All right, so here we have 8 m's, here we have 6 m's, and here we have 4 m's. Okay, so the most that we could take from all of those would just be 4 m's. Okay, so one of the tricks is that if it's in standard form, the greatest common factor for the variables will always be the smallest exponent. Okay, if we have an example where it's maybe like x squared plus x plus 1, okay, here this would be our smallest exponent, or it would just be a constant. Okay, you could always put x to the 0, which would be equal to 1, so that wouldn't change anything. But whenever you have something like that, you can't factor out any of the variables. Okay, it would be already simplified, or already factored. All right, so here, m to the 4th would be our greatest common factor. We divide top and bottom by m to the 4th. Okay, so we'd still have m to the 4th on the left side. Okay, 2, can't simplify the 2, but we have m to the 8th divided by m to the 4th. Okay, so 8 minus 4 gives us m to the 4. So basically we're taking away 4 m's, leaving us with just 4 m's. Okay, plus 8m, okay, we have 6, take away 4, that leaves us with m squared, and then we would end up having 7. So m to the 4th divided by m to the 4th, okay, those are the same, we'd end up just getting 1. So that's why we have a negative 7 times 1, which is just negative 7. Okay, all right, and then D, just another example, greatest common factor. I had a lot of students in class say, well, is the greatest common factor a negative y? Okay, well, the thing is that it's always going to be, we only factor out a negative if the leading term is negative. So if there was a negative here, then yeah, for sure, you would take out a negative. But since our negative is not in the leading term, it's at the last term, in fact, all we can take out would be a y. So we'd end up having y equals 5y to the 5th plus y squared minus 1. Okay, so if you have any questions on these, let me know. Hopefully that kind of helps clarify some things. If not, just stop before school or something and I'll help you out. Okay, so number 4, we are doing the greatest common factor again, but this time we have both numbers and variables that we can factor out. So you kind of do them one at a time. So for numbers, what would be the greatest common factor for the numbers? We could take out a 2. 8, you can divide 8 by 2, you can divide 2 by 2. Okay, and with the variables, again, we would look at the smallest exponent would be m to the 6th. We divide top or bottom as well by 2m to the 6th. And would end up getting 2m to the 6th times, well, 8 divided by 2 gives us 4. Okay, we have 8 minus 6 gives us m squared. And then would end up having minus, okay, since we have 2m to the 6th divided by 2m to the 6th, would end up just getting 1. Okay? All right, so pause and do B, C, and D if you can. Okay? Checking first, we have standard form, 5, 4, 3. Okay? Standard form, great. Next, we'd want to do the greatest common factor. So look at the numbers first. We have a 6, a 2, and a 10. I would say we could probably factor out a 2. Okay, again, we have a leading negative, so we'd have a negative 2. And then for the variables, this is our smallest exponent, so we'd have x to the third. We'd divide everything by negative 2x to the third. So we have negative 2x to the third times, okay, so we have a negative 6 divided by a negative 2. That ends up giving us a positive 3. And then we have a 5 minus a 3 gives us an x squared. So it's just the difference between those. Okay, 2 divided by a negative 2, well, that would end up giving us a negative 1. And then x to the fourth divided by x to the third. Well, 4 divided by 3 gives us 1. So all we have is x to the 1, which is just 1. Again, you wouldn't need to keep that 1. It could just be a negative x. And then we would have a negative 10 divided by a negative 2 gives us a positive 5. And then x to the third divided by x to the third just gives us 1. Okay, so that would be our solution for that example. Here's another example. So we'll make our parentheses. It's in standard form. We have our 4, we have our 3, we have our 2. Okay, then we want to say what is the greatest common factor for the numbers. Okay, well, oftentimes it ends up to be the smallest, but not always the case. And we could come up with some examples doing that too. But here we can divide 3 by 3, we can divide 6 by 3, and we can divide 24 by 3. So it would be the smallest coefficient. Okay, and then the smallest exponent would be the x squared. So 3x squared. End up having 3x squared times, well, 3 divided by 3 gives us 1. And 4 minus 2 gives us 2. We have a negative 3 divided by 3 gives us a negative 2. And then a 3 minus 2 gives us a 1. So x to the 1, which is just x. And we do 24 divided by 3. That would end up giving us 8. So positive 8. And then x squared divided by x squared would just give us 1. Okay? And that would be it. D, okay, it's not in standard form. I had so many students when I started this, I was like, okay, give this a shot. And everyone just started and they started factoring out a negative because they thought that we had a leading negative. But remember, we need to have it in standard form, so which would be 21y to the 7th plus 7y to the 5th minus 7y to the 4th. Okay, so we'd make our parentheses. Greatest common factor would be a 7 and a y to the 4th. So we'd have 7y to the 4th. And then in parentheses, we would have, well, 21 divided by 7 is 3. And 7 minus 4 gives us y, not x, y to the 3rd. And then 7 divided by 7 gives us 1. And then 5 minus 4 gives us y to the 1, which is just y. Again, you wouldn't need to have that 1 for the coefficient. And then we'd have negative 7 divided by 7 gives us a negative 1. And then 4 minus 4 gives us 0. And we know that y to 0 is just 1. Okay? So 1 times 1 would just give us 1. So we'd be done. Okay? Or you could think of that as just canceling out. Okay, so that is the greatest common factor. If you have any questions, please let me know. And then the next page, we talk about factoring by grouping. Okay, factoring by grouping only works when we have 4 terms. Okay, I imagine actually you could probably do it for other terms, but in our class, we're only going to be using it when we have 4 terms. I guess you could do it when you had probably 6 terms or 8 terms, probably any even number of terms greater than 4. Okay, but we're just going to be doing it when we have 4 terms. Okay, so anytime you see 4 terms, think grouping. Okay, so basically what we're going to do is we're going to try and break this into 2 parts where it's more manageable. Okay, so the first step says to group the first term or the first 2 terms together and the last 2 terms. So we kind of did that by just doing a vertical line. All right, after that, we factor out the GCF of the left side, and then we do the right side. So the greatest common factor for these first 2 terms, okay, well, for numbers, we can factor out a 4, and we can also factor out an x, okay? So this would be our smallest variable, or I mean coefficient, okay, and this would be our smallest exponent. So we would still need to divide it by 4x to simplify, or I mean to keep it equal. So we'd have 4x, and then in our parenthesis, well, 4x, or 4 divided by 4 is 1, and 2 divided by 1 gives us 1, so we just end up having an x, and then 20 divided by 4 gives us 5, and then x divided by x is just 1. All right, so we did the left side, let's do the right side. All right, so we'd make our parenthesis. So what would be the greatest common factor? Well, since this is in standard form and we have a leading negative, okay, we would need to factor out a negative 3. Okay, so there's not a lot of room to put in here, but usually I would have it in right here. So negative 3, and then for the variables, okay, we can only take out a y. Can't take out any x's because there's not x's in both terms, but there's a y in both terms. So we can factor out a negative 3y, right? And then we need to divide it by a negative 3y as well. So we'd end up having a negative 3y or minus 3y. Would have our parenthesis. So we'd have, here we have a negative 3 divided by a negative 3. Well, that just gives us 1. And 3 divided by 3, well, that just gives us 1. So all we have left is an x. And then for the right term, we'd have a negative 15 divided by a negative 3, and that would give us a positive 5. And then the 3, or the y divided by y, that just gives us 1, or it cancels out. So we'd just have x minus 5. Okay, so now if we look at what's in the parentheses, okay, we realize that what's in the parentheses is exactly the same. Okay, and that will always be the case when we're doing grouping. At least we will have problems where you can group. They won't have any examples where you can't group. I mean, it would be easy to make ones where you couldn't. Like, for example, if this was a 19, obviously we wouldn't be able to group because we wouldn't be able to find these 2 parentheses that would be the same. All right, but here they will always have 2 parentheses and they will be exactly the same. If for some reason they're not, then you should go back to your work and make sure that you did it right. All right, so at this point we basically have 2 terms, and if we were to try and factor out the greatest common factor, basically what do they have in common would be the x plus 5. So if we kind of do the same sort of situation, we could put x plus 5, and then we could divide the whole thing by x plus 5. Okay, and you'd notice that that would cancel, and all that we would have left would be 4x minus 3y. Okay? That said, okay, what I usually tell the students, trying to kind of simplify so you don't have to write so much stuff, is that once you have those two parentheses that are the same, we will take them out, x plus 5, and then everything else that's not in those two parentheses will go into the other parenthesis. Okay, so it just saves probably, so you don't have to write as much, probably wouldn't make as many mistakes. All right, so let's do another example. Okay, again, first thing is to group it into two. Find the greatest common factor. So for the numbers, the thing we could factor out would be a 3. Okay, and the smallest exponent would be x squared. So we divide it by 3x squared. So 3x squared, and then our parenthesis we would need to simplify. So 3 divided by 3, maybe I'll use a different color. 3 divided by 3 gives us 1. And here we have 3 minus 2, well that leaves us with 1, so we just have x to the 1, which is just x. Okay, and then we would do negative 6 divided by 3, well that gives us a negative 2. And then we have our x squared divided by x squared, that's just 1. Okay, all right, and then here we're going to do this, the right side. So greatest common factor for that would be 15. So we'd divide it by 15 as well. So we'd have positive 15. And then inside the parenthesis, we would have 15 divided by 15 is 1. So we just have x. And then 30 divided by 15 is going to leave us with 2. So we'd have negative 2. So again, what's in our parenthesis is the same. We'll bring that out, x minus 2. And then everything else will go into a different parenthesis. Okay? Hopefully that makes sense. Okay? So we're just factoring, basically we're factoring out the x minus 2. So this would be our new GCF. Okay? All right. So if you can, pause and do these last 4 problems, and then you should be good for the homework. All right? So hopefully we're feeling good. I'm going to do one more kind of slow, and then we'll speed up a little bit more. Okay? So greatest common factor here would be 4. And for the variables, it would be x squared. So 4, and this is the smallest, and this would be the smallest. Okay. And so, like I said, let me give you an example of where the smallest wouldn't necessarily be. Okay, so if we had like 3x to the third plus 8x squared, okay, if we had to do the greatest common factor, obviously 3 is the smallest coefficient, but we can't divide 8 by 3. So we can't necessarily always take the smallest as our greatest common factor, okay? All right, but the smallest exponent you can always take that one out, okay? Okay, so here we go. Divide it by 4x squared. So we'd have 4x squared, and then our 4 divided by 4 would leave us with 1. They cancel out. And then we have 3 minus 2, end up giving us x to the 1. Okay. And then 8 divided by 4 gives us a positive 2. And then the x squared divided by x squared, those cancel out. Okay. Right side. All right, so this is kind of a different case. So looking at that, like, well, we can't factor out a greatest common factor. Okay. But you can always factor out a 1. Okay, sometimes that makes it, or at least it looks better when we do these things. So plus 1, and then we'd have our x plus 2. Okay, so now we're doing the same sort of thing. We take out the parenthesis, x plus 2, and then everything else would go inside. Okay, so if you didn't write this 1, then maybe you would get a little confused of what you're supposed to do. But if we factor out the 1, then we always know that that's what's going to be our second term in our parenthesis. And when we're doing it by grouping, you'll always get 2 terms in each parenthesis. All right, D. Okay, let's go a little faster. Greatest common factor is going to be 3, and for the variables, we can only take out a y, so 3y. Okay, divided by 3y would end up getting 3y, and then the 3 and the 3 would cancel out, the y and the y would cancel out, all we'd have would be an x, and then negative 25, or 21 divided by 3 gives us a negative 7, and the y would cancel out. Okay, so the right side, we can factor out a 5. So we'd have plus 5. Remember that we always have a positive or adding or subtracting. Okay, don't leave it empty and thinking that you're just multiplying or something. Okay, so we'd have x minus 7. Okay, again, these are the same. So we did something good, something right. So we'd have x minus 7, and then everything else will go in the other parenthesis. Okay? Okay, now we have some where we have x's and y's. Maybe I did that already. I did for D. Okay, so this one kind of the same. So what is the greatest common factor for the x's? Okay, well, we can take out an x squared for both of those terms. We can't take any y's out. Okay, so we'd have x squared times y minus 3. And then for this one, okay, when you make those parentheses, if it's negative, keep it in there. So we could take out a negative 8. So we'd have minus 8 times y minus 3. So your answer would be y minus 3 times x squared minus 8. And finally, F, group, cut it in half. Okay, greatest common factor here. You could divide 8 and 6 by 2, and then we could take out an x squared. Right. Okay, and then would end up getting 2x squared times 4x plus 3. And here, greatest common factor, since it's a leading negative, we'd have to do a negative. And then we could do 6. Okay, so minus 6 times, we're going to divide it by negative 6. So that would give us 4x plus 3. Okay, so we'd have 4x plus 3 times 2x squared minus 6. Okay, now let's look at this. Okay, I should have done this before, okay, but we'll catch it here, and I imagine sometimes you'll miss it, and you'll have to correct it at the end. Okay, but when we look at this original problem, we have 8, 6, 24, 18. Can we take out a greatest common factor even before we group? Okay, and we sure can. We can divide all of those by 2. So we could factor out the greatest common factor first, and then we could do our grouping. Okay, so maybe I'll do an example of that. So say we factor out that 2, all we'd end up having, let me zoom in over here, maybe more room over here. So 2 would have 4x cubed plus 3x squared minus 12x minus 9. Okay, so here we would have the greatest common factor out. Okay, and then we would still do our grouping, but we would just use those 4 terms. We'd kind of leave the 2 by itself until the very end. So here the greatest common factor for this would just be an x squared. So we'd end up having x squared times 4x plus 3. And then for this side, greatest common factor would be a negative 3. So we'd have minus 3 times 4x plus 3. So we'd have 4x plus 3, and then we'd have x squared minus 3. And then here you would bring that down, and we'd put our 2 out there. Okay, so this is fully factored. If we look at what we had before, what do you notice the difference? Okay, you probably realize that, oh, well, this is the same. This is not the same, but it looks like we could factor out a 2. So here what we would do is we would do 2 times, basically we'd put a 2 out here and we'd divide this by 2. Maybe I should change my color. So 2 divided by 2, okay, we'd end up getting 2 divided by 2 is 1, and that would end up giving us 3. So we'd still have our 4x plus 3, and then we'd have x squared minus 3, okay? And then we'd end up having the same answer that we had here, okay? So whether you take out the greatest common factor at the beginning or if you do at the end, either you can have the same answer, okay? So look for that. I'm not sure that there's any in the homework, but you should always factor out the greatest common factor. Okay, we'll have other ones where we're not grouping, we're doing some other type of factoring, but you still need to take out the greatest common factor. All right, so let's just look at the homework really quick. I went over just a few of those together. So here, again, we have a leading negative. So all we need to do is the greatest common factor, okay? It says factor out the common factor for each expression. So we're not grouping here. Grouping will be the next page. But here, the greatest common factor here, since it's a leading negative, the negative includes it. So we could factor out a negative 2. Okay? So we'd end up getting negative 2 times, well, 14 divided by a negative 2 gives us 7v squared. And then negative 20 divided by negative 2 gives us a positive 10. Okay? An example where it's not in standard form, we would need to rewrite this as negative 6r plus 42. Okay? If you didn't, you probably wouldn't think of factoring out the leading negative. Okay, so here we'd factor out a negative 6. We'd get negative 6 times r minus 7. Okay? If you didn't do that, then maybe you would say, well, I'm just going to factor out a 6. Okay? And if you do that, then you end up getting 6 times 7 minus r. Okay? And when we're doing these things, this wouldn't be standard form first. And second, if we ended up having a negative r plus 7, and we, in other examples, we'll need to simplify further, not like this example, but others that have leading negatives, we would get our answer incorrect because we had a leading negative. So make sure standard form and leading negatives removed. Okay? All right. Somebody was asking, like, what do we do when we have multiple variables? Okay, here we do the kind of same thing. We'd look at the numbers. So what would be the greatest common factor for the numbers? Well, since it's a leading negative, would have a negative. And then we can divide each of those by 8. Okay, now we would look at just the x's. So what would be the smallest exponent? Okay, well, the smallest exponent would be x. Okay, now we'd look at the y's. Smallest exponent for the y's would be y. Okay, so that would be our greatest common factor. We could just divide it by negative 8xy, and you'd end up getting negative 8xy times, okay, well, negative 8 divided by a negative 8, that ends up giving us 6. positive 6. Okay, x squared divided by x, that gives us x to the third. And y divided by y just gives us 1. Okay, 8 divided by a negative 8 gives us a negative 1. So here, let's maybe take away that positive, make it be negative. X divided by x gives us 1, and y squared divided by y just gives us y. Okay, and one thing I didn't mention is if you ever want to double check your answer, you can always do the opposite of what we're doing. Opposite of factoring is distributing. So if you wanted to, you could distribute these back out and you would make sure that you had it exactly the same. Okay? All right, one last thing. We didn't really cover this in the notes, but here we want to find two numbers that satisfy the following. Okay? Two numbers that multiply to 24 and add to give us 10. Okay? So sometimes if you get stuck, I would start listing things that can multiply to give us 24. Well, we could do 1 times 24. We could do 2 and 12. We could do 4 and 6. Those are the only choices. Okay, but which of those can we add up these numbers to give us 10? Okay, well this would be 25. This would give us 14. And this would give us 10. Okay, so 4 and 6 are the numbers that can multiply to give us 24 and add to give us 10. And you may be wondering why we're doing this, but I will tell you all about that next time in class. All right, thanks.